Quest parents, this is Mrs. Bond, and I thought I'd send you a quick video about a new strategy that we are using for finding the GCF, or greatest common factor. So, quick example, for this problem A, we're finding the GCF of 42 and 56. For this strategy, we make like a tic-tac-toe board. We write our two numbers in the top right column, so we have 42 and 56. And we think, what is the number that both of these are divisible by? We're going to start with something easy like 2. So we do 42 divided by 2 is 21. 56 divided by 2 is 28. Then we stop and think, is there anything else that both numbers are divisible by? They are both divisible by 7. So I'm going to write that over here. I'm going to do 21 divided by 7 is 3. 28 divided by 7 is 4. And now I'm looking here and I'm thinking, is there anything that both of these numbers are divisible by other than 1? And the answer is no, so I can stop. And by the way, we call that relatively prime, which means they're just prime in relation to each other. There's not another number that you can divide them both by other than 1. After that, last step is we take all the numbers that were B over here, multiply them together, so 2 times 7 is 14. And now 14 is our GCF. So the answer to A would be 14. The way that this is especially useful, and you'll see it in question number 3, is that you can use this in order to find what you could divide fractions by, the numerator and denominator both by, in order to get the fraction's simplest form. So in this case, we would find the GCF for 48 and 64. So if we do, they're both divisible by 2, and we get 24 and 32. We think, they're both divisible by 8. 24 divided by 8 is 3. 32 divided by 8 is 4. Oh, we're at the same spot where we can stop. And now we multiply these together. 2 times 8 is 16. And what that leaves us is that we're able to take this fraction and say, okay, if I divide the numerator by 16, and I divide the denominator by 16, then that will give me this fraction in simplest form. So I hope this has helped. As always, if you have any other questions, please feel free to email me, and have an awesome night.